Okay, so kato to measure the errors. So now we will measure the precisions. So to measure the precisions, we have standard deviations. So standard deviation describe the spread of data around the mean. And then we can also use RSD, CV, and the variance. So for precisions, we can for standard deviation, we can use the function sa atong calculator to solve the standard deviations. Pero if wala, then we need to familiarize the formula. For RSD, familiarize the formula. RSD is equal standard deviation over the mean times 100. Pwede po RSD is equals standard deviation over mean times 1,000 in PPT. However, in CV, so this is the RSD in percentage. So CV is equals standard deviation over mean times 100. The variance, atuara ning squared ang atuang standard deviation, makakuha na din taog variance. So if given naman ang variance, then atuara siyang square root to get the standard deviation. Okay, so we will now have a example. So the following results were obtained in the replicate determination of lead content of blood sample. So 0.752, 56, 752, 751, and 0.760 ppm. Find the standard deviation of standard deviation, variance, relative standard deviation in parts per thousand, and the coefficient of variation for this set of data. So, again, to calculate, pwede ra gyud nato gamiton ang function nato sa calculator. So, for those calculator nga kasyo, so mode, nadira mode, dayon, mode 3, I think, for stat, and then nadira mo gawas nga 1 minus var, mao din to inyong gamiton, 1 minus var. Then, input the data. Then, use the function shift. Pag ma-input na ninyo ang data, shift, dayon na ay stat, number 3, manata, or number 1. Ay, number 1, rather. 1, and then, naadira ang mga value na need nyo pwede na to ma-use. Pero if wala, tayo calculator nga, magamit for stat functions, pwede ra nga ato siyang i-manual. So, to calculate the standard deviation, we will calculate first our mean. So, to calculate the mean again, add the given, add na nato, and then divide kung pila siya kabuo. Okay. Mean is equals 3.771 divide 5 is equals 3.771 divide 5 equals 0.7542. That is our mean. And then, for standard deviation, SD is equals use the formula. So, kani, kay iyahan na siyang gi-squared daan. Kani is squared, mao ni siyang answer. Kani ay squared, mao ni siyang answer. Kani is squared, mao ni siyang answer. Kani is squared, mao ni siyang answer. Dayon, kani, o kani, ato siyang i-sum. Mao dayon ni ang iyahang answer. So, okay. So, SD is equals, use the formula. SD is equals 2.84145 minus formula na to. Then, kani, summation, 3.771 squared over the number, kung pila siya kabuok, this is 5, divide 5 minus 1. So, SD now is equals, so if i-use ninyo inyong calculator, SD is 3.77, I think, times 10 to the power of 3, negative 3. Or 0.00377 ppm. And then for variance, atuara ni siyang e-square, 0.00377 square, that is 0.00377 squared is 1.42 times 10 to the negative 5. So, to calculate the RSD is equals, so to ang formula, standard deviation over mean times 100. Standard deviation kani, so 0.000377. By the way, in calculating the katong number na wala pa ninyo siya significant figure, mao dito atong i-use for succeeding na mga calculations. So, we will have SD for that. 2.844145 minus 3.771 divide 5 over 4. So again, pag napay succeeding na calculation, use the value nga katong wala pa ninyo siya na round off or katong wala pa ninyo siya gi-follow og significant figure. Kani kay naka-follow na siya og significant figure, pero if ako ani siyang i-calculate ang SD, I think ang iyang ihatag kay 3.768,88736 times 10 to the negative 3. So, kani inyong gamiton. So, again, use the katong value nga wala pa siya na round off. So, 3.768288736 times 10 to the negative 3. Divide the mean, pila ang mean? Kani 0.7542 ppm. So, RSD times 100 is equals pila 4.99. 1,000 pala ang RSD because naka PPT dahil siya direct parts per thousand. 4.996 PPT. This is the answer. For CV naman, standard deviation divide mean times 100. So same, 3.768288736 times 10 to the negative 3 divide 0.7542 ppm times 100 is equals 0.49986 or 0.500%. Kani following the significant figures 5.00 PPT. Kani following the significant figures 0.754 ppm. So again, to calculate first the ppm. Wait, I will change my Okay, again, to calculate first the ppm, then for standard deviation, summation, nadira. And then, pag napay succeeding na calculation, use the value nga wala pa siya na round off. And then, kani, this is the RSD in PPT, kani, the CV. Excuse me. Okay, so for this one, okay, sorry. Okay, so for this one, this will be your practice problem. So you will try on your own to calculate the kaninga problem. Okay, reporting computed data. So significant figures, these are the certain digits plus the first uncertain digits. So follow the rules in significant figures in reporting data after the computations. So significant figures, laboratory investigation usually involve taking of an interpretation of measurements. So we use meter sticks, thermometer, electrical meters, clocks, and others. Okay, so significant figures consist again of all certain numbers in a measurement plus the first uncertain digits. So for the first instrument, kani, we have less significant figures in this 2. And then kani, we have 3 significant. More likely, this one will give more accurate data. Kani naman, balance, less significant, natay significant, 12, and then 1 na uncertain digit. Kani, we can say nga, kani nga balance is somewhat accurate na data. Because we have upat kabuok nga certain ta dayon na rin ta isa nga uncertain. Okay, this will be the rules in determining the significant figures. All non-zero digits in a measurements are significants. So for example, 237 3 significants, 1.897 4 significants. Interior zeros or zeros between non-zero numbers are significants. So 39,004 5 significants. Then kani na siya decimal point pero na 0 sa tunga, also a significant. Leading zeros, kanang mga nag-una nga zeros, dili siya significant. So for example, 0.008, 1 significant lang siya. 0.000416, 3 significant. Trailing zeros, kanang trailing zeros at the end, kanang mga end sa numbers, significant lang sila if na ay decimal point. So for example, 1,400 point. So natay 4 significant figures. Pero kaning 1,400, 2 significant figures. So again, for 1,000, 1 significant figures, or 190, 2 significant figures. For scientific notation, kung pila ni diri, mao na ang ato ang significant figures. So 1.4 times 10 to the positive 3, 2 significant figures. 1.40, 3 significant figures. Kaning 10 to the power, wala ni siya i-appeal sa significant figures. Okay, in addition, significant figures in numerical computations, in addition and subtraction, ang ato ang pag-follow sa significant figure must be the lowest number of decimal places. So if naatay 2 decimal places, then our answer should have duha pod ka decimal places. So kani we have 1 2 3 4 4 ka 4 decimal places, kani kay duha lang. So our answer must have 2 decimal places. For multiplication and division, the lowest number of significant figures mao dapat ang ato ang answer. So for example, kani 3 significant figures, kani kay 5 significant figures. Kani 2 significant figures. So our answer should have 2 significant figures. True for multiplication and divisions. In logarithm, so the number of kaning naa diri sa diba dira mao man na ato ang significant kung naka scientific notations. So if ang ato na siyang i-decimal point, i-calculate ang logarithm, then kung pila ni ato ang significant diri, maupod ang ato ang decimal point for logarithm. For anti-log, baliktad. So kung natay duha diri ka decimal point, natay duha pod ka significant figures. So mura ra gog kabaliktaran ani, kani kay tatlo siya ka SF. So ay tatlo siya ka decimal point. So ang iha pong log kay naapoy tatlo ka significant figures. So again, any digits is non-zero, not zero is significant. Zeros between non-zeros, significant. Zeros leading zeros, dili siya significant. Zero after the decimal point, significant. Zeros, mga trailing zero, significant pag naay decimal. Pero pag wala, dili siya significant. Okay, exact numbers. So numbers from definitions or number of objects are considered to have an infinite number of significant figures. Another, like for example, calculating mean. Diba, calculating mean. So katong pag-calculating nyo sa mean, ang inyong pag-determine sa significant figure must be relate sa dito sa inyong given. For example, kung naay 3 ka buok significant figure ang given, then 3 po dapat inyong report. So, unsa pa ang mga infinite kanang mga mga infinite nga mga significant figures, molar masses, infinite na sila. So, if naatay calculation, so we must follow sa pila ang significant figures nga naa dito sa given. Given ang atong tan-awon. So how many significant figures are in each of the following measurement? So 24 duha, 2 significant figures. Kana to nasa to nga significant, kana leading ang isa, dili significant, pero kani significant. 3 significant figure. Then, kana duha. Kana duha gihapon. Okay, for scientific notation, this is just a review. So, pag negative, pasabot, ang atuang decimal point kay atuwa siyang i-move to the left. Pag positive, to the right. Pag kani positive, to the right ni iyahang move sa decimal point. Okay. So, I think okay ra ni siya. Kaya ra ni siya sa calculator. So, again, for this one, practice problem. Practice this one sa inyong own. And then, that ends the topic 2, the errors of chemical analysis.